This is the last experiment. This is experiment number 3, and this time we will only use fixed noise with unit standard variance in the training process. So this means that we will not need the variational loss anymore. So our Lagrange multiplier now will become 0. So all this will be 0, and we will have just the mean squared error. And now our Y encoded standard deviation will be ones with the same shape of the mean. So everything stays the same. We are using the same training set with the same audio files. But here now, here instead of using the standard deviation values from the network, we are using the unit standard deviation. And also here, we are setting the Lagrange multiplier to 0. So our loss is just the mean squared error. So we will train the model, and it will be exactly the same procedures like we did in the other experiments. And then we have also the weights and the encoder and decoder filter coefficients, and we already notice this very prominent analysis filter 0 for the STD. And here now we will test using the audio files from the training set. Listen now, so this will be the output for the clean encoded signal.
Let him who hath understanding reckon the number of it.
Here is the output for the noisy encoded signal.
Let him who hath understanding reckon the number.
And here for the batch 1, so the other audio file.
We shall fight with growing confidence and growing strength in the air. We shall defend.
And here is the training set for noisy encoded. So we add the noise for the previous audio file, the same as this one, so it's batch 1.
We shall fight with growing confidence and growing strength in the air. We shall defend.
We see there's a lot of noise in the background, but we can still understand the original file. And we see also that the standard deviation now is a constant 1. And here we have the target and the predicted signal for batch 0, for batch 1, and we see that after training we have the plot with the added noise, so that it's indeed a constant 1 like we seen before. And the playing back the clean signal, we can hear that this sounds somehow less clean than the first experiment perhaps. So it seems to be more robust against noise in the encoded domain, or at least for the files used for training the model. But now we will do again with a verification set. So this is a part of the audio that the model never seen. So this is the input.
We shall go on to the end. We shall fight in France. We shall fight on the sea.
This is with the clean encoded signal. And here is with added noise, so the noisy encoded signal. And here when we use only noise as the input. And here we have the original in blue and the predicted in orange. So again, we see that in both cases it produces a mix of the training set speech pieces. So with noisy encoded, and we use just noise as the input. And we have to keep in mind that in this last case, it has the advantage that it does not need a neural network for the standard deviation prediction. So what we did It's just we set it to a constant standard deviation to 1. So that's it for this tutorial. This is a very basic and short introduction to variational autoencoders. It's more to give some insights and intuition and to start to understand the basics, the theory behind it. And I encourage you to explore more other tutorials that are available online and play around with bigger data sets and experiment with different network architectures, different hyperparameters depending on the problem you're trying to solve. And I see you next time.